A wooden ball floats in water. Some of the ball is above the surface. The mass of the ball is 60 kilograms. Its volume is 0.2 meters cubed. So let's draw a little picture of the ball so we can get an idea of what we're working with. And its mass is 60 kilograms. And its volume 0.2 meters cubed. So we want to know all about it, and let's start with its weight. And we remember that weight equals mass times gravity. So 60 kilograms times, we'll use the simplified 10 meters per second squared, and we're going to get 600 newtons. So let's even just go ahead and draw that in. Newtons. Alright, so find the density of the ball. So we know that density equals mass over volume. And we know that the mass is 60 kilograms. Oops. We know the mass is 60 kilograms and the volume is 0.2 meters cubed. And so I believe that gives us 300 kilograms per meter cubed. So let's find the buoyant force on the ball. So the easiest way we can do this is to just look at the ball and see, well, it's not accelerating. There's nothing in the problem to make us believe it's accelerating. So we know F net is 0. And so that means that the buoyant force must be equal to the weight force. And since we know the weight force is 600 newtons, the buoyant force must also equal 600 newtons. Find the volume of water displaced by the ball. So now we want to look at this relation for buoyant force. FB equals rho sub F times V sub F times G. So rho sub F is the density of the fluid. So the density of the fluid in this case is going to be 1,000 kilograms per meter cubed because we're working with water. So the volume of the fluid displaced is what we don't know. And we know G. And actually we do know FB, so let's go ahead and fill that in. And that's 600 newtons. So if we solve that out, divide it by 10, divide it by 1,000, I believe that's 0.06 meters cubed of water will be displaced. Okay. And so this final question. So salt is now added to the water. Will the ball float higher or lower? Alright, so let's look back again at this quantitative relationship. And let's see, what are we changing here? And what's staying the same? So if we add salt, the density of the fluid is going to increase. And we know that the ball is going to come to rest and the buoyant force will be equal to the weight force. So the weight force is not going to change, so the buoyant force is going to have to remain the same, but the amount of water displaced will have to be lower because the density of the fluid has gone up. So the ball will displace less water, and thus it will float higher